Welcome to the factoring trinomials lesson. So what we've done in the past that's related to factoring trinomials is we expanded binomials. So binomial, like there's two terms. So for example, x minus 5 is a binomial. Um, in grade 9, you took a monomial, which is like the one term, the two here, and multiplied it with the binomial using distributive property or the rainbow method and so forth. And then earlier this year, this semester, we looked at multiplying binomials. So a couple, there's two terms here, multiplying them together. So in the end, there's 4 calculations to make. So what we're going to do today is we're going to reverse that process, okay? And that's why it's called factoring. So I just want you to make sure that you get comfortable with the terminology here. Expand means to multiply out, okay? And then it's like you have to break through those brackets, multiply all the terms through, clean up any that you can add together, and then, yeah, write your final answer. Okay, but factor is the opposite. Okay, so you're going to reverse what you did. So here you're looking at, there's like a binomial here, but we're going to divide out something that they have in common. Here we're going to reverse it so it'll look something like this where they're two binomials multiplied together. Okay, so I'm going to just review how we are supposed to expand questions and then quickly show you what factoring looks like before we actually start doing the factoring stuff. Okay, so if we want to start here with the monomial times the binomial, so what you did in the past, you use the distributive property, or we call it the rainbow method, because we're going to take this 2 and multiply it here, and then don't forget to also multiply it there. So when we do that, 2 times x is 2x, 2 times negative 5 is negative 10, okay? You expanded it, the brackets are gone, and that's your final answer. For the next one here, x plus 2 times bracket 3x minus 4. We need to use this new FOIL method or area model method. So some of you guys like to use the boxes, or some of you like to go first, outer, inner, last. Okay, but just remember there are 4 calculations or multiplications that you need to make, and then you collect any like terms that you can and simplify your answer. All right, so I'll try the FOIL method first. So we're going to use the FOIL method here. So remember, FOIL stands for first, outer, inner, last. So let's write that here. First, outer, inner, last. Okay, so we're going to take the first 2 terms in the binomials, okay, and multiply them together. So we have 3x squared. Okay, and then we're going to take the outer 2. So it's like you're distributing this x to both of the ones on the second bracket. So the outer 2, x times negative 4 is negative 4x. And then inner, we'll take the inside 2. So now this 2 is distributing to both in the second bracket. So 2 times 3x, 6x. And last, these 2 will multiply together. So 2 times negative 4 is negative 8. Okay, and then there's always this cleanup step. Check for any like terms. 3x squared, it's by itself. But the negative 4x plus 6x, you need to combine those together. So think negative 4 comes in and battles 6. 6 has more players, so positives will win by 2x and subtract 8. Okay, and so that is how you expand the binomials here. So you're multiplying the binomials here. And for this one here, it was a monomial times a binomial. Okay, so that's what we did in our previous unit. So in grade 9, you kind of covered something like this, and then grade 10, this was the new stuff. So now you're going to do the reverse. You're going to go back to what you needed to get to. So I'm just going to quickly write out the answers for this next part here. So factor, okay, it's the opposite of expand. You need to divide out the common factor here. So we just covered some of the stuff here. So we would write, GCF. So you're thinking 2 and 10. Okay, the greatest common factor is 2. There's no letters, so then we are going to divide out a 2 out of both of these. Okay, and then you always write the greatest common factor outside, and then divide 2 divided by 2, x. 10 divided by 2 is 5. Okay, and there you go. So you went from a binomial and you reversed it and went back to this monomial times the binomial. So it's like this example. It's exactly this example here. But so we've already completed this lesson here. This was the common factoring lesson. That's whenever there's a monomial multiplied in. But now the new stuff here is how do we get a trinomials, there's 3 terms here, back to the binomial times binomial. Okay, so we're going to learn that today. So I'm just going to write in the answer here. So we need to get back to getting the expression to look like that. So we're factoring it out. Okay. So before we move on, I just wanted to go over the area model again for people that do like to expand these binomials that way. So we're just going to write it underneath here, just squeeze it in. So we have the expressions. You have to expand x plus 2, 3x minus 4. So you have to expand that. So you're going to make your little box up here. So we're going to put one of the binomials here. So it doesn't matter where, just take one of the binomials, put it along the side. You can put it here, you can put it down here. Okay, so I'm just going to put x plus 2 here. Okay, and I'm just going to write the plus 2. I know I haven't done that in the past, but I think it'll help with, especially when there's a negative. So 3x, and then subtract 4 like that, just so you know if you're multiplying, just to remind you you're multiplying by a positive or negative. Okay, so what you want to do here is now with your box method, you are multiplying the 3x times the x here makes 3x squared. The x times the negative 4, negative 4x. 3 times 2, 6x. And negative 4 times positive 2 is negative 8. Okay, so again, I know that not everyone likes to use this method, but it's always good to keep an open mind and try lots of different ways of doing a question, because later on this box method might become useful when you kind of tackle some more complex questions in the next years coming up, so, or even this year. So just keep an open mind, keep looking at this, and then you might even want to use it today. Okay. All right. So just to finish it off, though, we need to take it out of the box, though. Okay. Always remember to do that for the people that use this method. Okay, so you're writing your final answer that's expanded is, okay, you're taking 3x squared out, and then a reminder, make sure that you are combining these two together, okay? So you get positive 2x, and the negative 8 comes out, okay? And there's your expanded answer. All right, so let's move on to the rest of this note here. So we're ready to move on into the factoring. So how do we go from this trinomial back to the 2 binomials that it calculated it out from? Okay, so again, we did FOIL or area method to get to here, area model method, and then we're trying to go backwards now. Okay, so again, when I say trinomial, we're looking at quadratics in this year. So you're always going to see that x squared, so there might be a number here like 3 or negative 2, or it might just be a 1 there, so there's no number there. Then there's that second term bx, so there's like a 8x or negative 5x there. And then plus c is the one with a constant, there's no letter, 4, minus 2, etc. So you're always looking at a quadratic relation here, okay? And we are going to be factoring these trinomials. So here's the first one. I'm going to teach you guys the decomposition method, a way to get it back to the original binomials by using decomposition, but I'm also going to teach you the area model as well. So again, be open to both, look at them both, and you might find that you want to use the area models at some point. So yeah, watch both methods, try both methods. Okay, so step one, just like what we were practicing in the past, you always have to look for a common factor. Okay, we always do this as we approach any of these questions. Always look for a common factor. So if it says factor, step one, look for a greatest common factor. Okay, so let's just do that here. So I'm just writing, I know a lot of you like to do this as well, so you just write CF or GCF. Okay, so make sure it's always the greatest one. So we're looking at 3, we're looking at 8 and 4. So 3, 8, and 4. Do they have a common factor that I can divide out of all 3? Okay, and no. Do they all have a letter that they can divide out? No. Okay, so the greatest common factor here is just 1, and so we don't need to take a common factor. So we're going to go to the next step here. So this step's done. Okay, so now I want you to analyze the A value, the B value, and the C value. Okay, so again, here is the A value. This one here, and the sign as well, is the B value. And this one here, without any letters, is the C value. Okay, so again, on top of it, we take the sign, so positive 3, positive 8, positive 4. So what you're going to do is you're going to create a product sum table. Okay, so we can call it like sum product. Okay, so a lot of people like to just write plus, minus, or sometimes they'll write add, multiply, whatever. Okay, so oops, we need a product here. Okay, so we need a sum here and a product here. So what we're doing is we're finding the sum of B and the product of AC, A times C. Okay, so if we do that here, B in our example here is 8. Okay, so we need to find the sum of 8. Okay, and we need the product of A and C together. So if you're looking here, A and C, so that's A and C. So I always tell people to kind of do that, put that little connector there so that you might remember, okay, make sure multiply those together. So that's 12. Okay, so we have a sum of 8 and a product of 12. Okay, so we're building our little table here. Okay, so now that we wrote our sum product table, so what we're going to do here is now we're going to think of all the numbers that make a product of 12. So what numbers multiply to make 12? So the two numbers. Okay, so you can go through the list. As you kind of work on these more and more, you'll get really good at finding the numbers. But for when in doubt, just go start with a 1. 1 times what makes 12? Well, 1 times 12 makes 12. And 2 times what? 6. 3 times 4, okay? And then from there, you've thought of all the numbers, but also keep in mind that because it's a positive 12 that you have to, a positive 12 that you have to multiply up to, you want to think of every possible scenario here. So you've thought of all the positive numbers, but remember, you can also multiply -1 and -12. Okay, that will make positive 12. -2 and -6 and -3, -4. Those also work to multiply to 12. Okay, so from there, the other condition that you have to find is that you need, so you're trying to find two numbers that multiply to 12, but then you're trying to find those same two numbers that will add to 8. Okay, so if you're taking a look through here at all these factors that you found, you have 1 plus 12. Okay, is that going to make 8? No. Okay, 2 plus 6. Oh yeah, that works. Okay, and then right there, as soon as you find the two numbers, you just stop and kind of go on to the next part, the next step. But yeah, here, I'll just go through though and add these all up, and then you're like, nope, that makes 7. -1 plus -12. No, that's -13. Okay, hopefully you see here. No, these do not work, okay? But you always want to try to think of all the different possibilities, because sometimes the negative times the negative is the number, the two numbers that you need to find, okay? All right, so we found that this one, we found that okay, these are the ones that work. Okay, so we found the two numbers are 2 and 6. So this method is called the decomposition method because you're trying to break up the middle term, 8x. So you're going to do that by decomposition. So we're going to write that trinomial now. Instead of 8x, we're going to write 2x plus 6x. Okay, so we're just starting the question again here. So we're going to go 3x squared plus 8x plus 4. We're going to decompose that middle term. Okay, and then we get to there. And then it's essentially what you're doing from here is you're factoring by grouping. We did this before with the previous lesson where once we have 4 terms like this, we're going to just kind of pair them up and factor them in pairs and then eventually get to a factored answer. Okay, so let's erase this here. Okay, so we have, I'll write this a little bit lower too. There's some space above. Okay, so it doesn't matter which way you wrote the two terms now. Like if they both add up to 8, so it's fine. So you can write the 2x first, or you could write the 6x first, whichever. Okay, so you're looking at these first two here, and you're looking for the greatest common factor. Okay, so you're looking at 3 and 2. There's no, just a 1 works, right? They both do have a letter, so the greatest common factor is x. The other one, you have 6x and 4, so the greatest common factor. They both can have a 2 that can divide out. They both don't have a letter, so just 2. All right, so now go through the steps of factoring it out. So you're going to divide an x here. So that means the greatest common factor comes out here. And then you write what's left. The 3 comes down with one of the x's. For the next one, just the 2 comes out, bracket. Okay, and the other one, so the greatest common factor is a positive 2. Okay, so that leaves a 3x. And, oops, so if I remember, divide the greatest common factor out of both of them. So you put the greatest common factor here, get 3x plus 2, like that. Okay, and then there's one more step after that. Hopefully you can see the common factor here. Okay, so they both have 3x, so I'm not going to skip a step because I don't want to confuse you guys. So hopefully you see here in this next step here that they both have 3x plus 2 in common. So what you're going to do is you're going to divide these both by bracket 3x plus 2, bracket 3x plus 2. Okay, and then we write that greatest common factor out here, and then what's left? Just the x plus 2. Okay, so it takes a little bit of work, but this is just one way to learn how to factor the trinomial, like this trinomial here. This is one, I know there was a lot of work here, okay? But this is just because you're learning to do it for the first time. This is a good way to kind of ease into it. But after a while, there's a few other methods that you can try, and you can get to the point where you can start guessing on like, okay, what two numbers do I need to put here to make 3x squared? Okay, well, 3x and x, and then throw some numbers in here by trial and error. You can get to from here to here really quickly. Okay, so but just to start off, just try this method. But if you can kind of sit there and kind of figure out a method right now and get to the answer, then that works great as well. Okay, all right. I'm going to show you the same question now using the area model. Okay, so the area model. Again, some of you may not have used it before when we had to expand the terms. You said you didn't like it, it was a lot more work, you didn't want to draw boxes and so forth. But you might find that, hey, you like this method better instead of the one above in order to factor the trinomial. So again, just keep an open mind. All right, so start off with drawing your 4x4, or sorry, 2x2 square. And I want you to put the A term and the C term into the box, okay? So if you take a look here. Okay, so you're going to put the A here and the C term here, okay? So remember, we have ax squared plus bx plus c. So you're going to put the A in this corner and the B in the other corner. Or sorry, the C in the other corner. So let's do that. Okay, so there it is, the whole term, x squared. Okay, so I guess we can write this as the ax squared term. Goes in this corner. Okay, and then the C goes in the other corner. That's the positive 4. Okay, so from there, we still need to do the product sum table that we did above. So I'm just going to do it again here, just to repeat. So we need the sum of B, and we need the product of A times C. Okay, so that is the sum of 8, that's B, and the product of A times C, which is 3 times 4, is 12. Okay, so again, if you're a bit tired, write them all out. Okay, and then if you find as you're writing them out, you find one right away. Oh, 2 plus 6 works. Then you just stop. You don't have to keep looking for all the other ones. Okay, it is important that you do, like if it is a positive 12 that you have to multiply to, that's what you have to do. And if it's a positive 8 that you have to add to, that's what you need to find. All right, so 2 and 6 work. So what you're going to do from there, it doesn't matter which, so those are the two numbers that we're going to add in the remaining boxes here. Doesn't matter which spot you put it. You could put the 2x down in this corner here and then the 6x up here, or vice versa. It still will come out the same. All right, so I'm just going to put the 2 here and the 6x there. Okay, so again, we found those from using the product sum table. All right, so from there, we need to reverse what we normally did with the area model. So we usually would have some numbers out here, and you would multiply and fill in the table. But now what you have is that you already have the table filled in, so you're going backwards, and you're trying to divide out some values here. So right now you're thinking, all right, let's go across the bottom row here first, 2x and 4. What do they both have in common that I can divide out? Okay, so hopefully you see, oh, I can divide out a 2 out of both of them. Can I divide out a letter? No. All right, so let's go to the next one. So again, across the row, and then we're going to write our answer here. So 3x squared and 6x. So what do they both have in common? Can I divide out a number? Yes, I can divide out a 3. Can I divide out one letter? Yes, I can divide out the most an x. All right, and then now let's go up and down. So we're going to go with these two here. So 3 and 2. 3 and 2. Can I divide out a number? Well, 1 works, but that won't change anything, so no. Then we go to the x squared and x. So the x is the greatest number of x's that we can divide out. All right, and the last column here, 6x and 4. I can divide a 2 out of both of those. Can I divide a letter? Nope. Okay, so once we get to there, This is the area model way of factoring. So you could see here now on the ends here that you have the two factors. So you need to, again, write your answer away from the box. And now you're going to say this trinomial that you started with, you have now factored it. And this is your factored answer. Okay, so 3x plus, so see how there's no negative, so it's just plus 2. And the other one is x plus 2. Okay, so put them in their own brackets. And this is the factored form. Okay, so if you're looking at this one here and you're looking at the one above, you ended up with the same answer. Okay, so some people might say, oh, I like this method a little better, a little quicker, fewer steps. Yeah, so that's why you might want to use this method, but again, it's up to you. In the end though, after working through this through a few cycles, I do want you to get to a guess and check method, which is faster in speed, and how efficiently you process these calculations and factoring and so forth is important for next year. Okay, so one other question I always get asked is, what if I wrote it the other way? So what if I just wrote it this way instead? Okay, does it matter? Nope, it's still the same. It's like you were saying 2 times 5 or 5 times 2, still the same. With the area model, if you had these like these the other way, you would have the 3x up here with the 2, and then you have the x plus 2 down this side. So it's okay, it still comes out the same. So that's pretty much what we're covering today. You're trying to factor out a trinomial. So I've given you a couple different methods. You can use the decomposition method. So again, it's called decomposition because you're finding the two terms, you're breaking them up, okay, and then you're doing factoring by grouping, and you get to your factors at the end. There's also the area model, same thing, go through, going from the trinomial and back to the factored form. All right, so let's try some examples here, some more examples. Okay, so I have it set up so that you have a decomposition side and an area model side. So if you have a preference for one or the other, you can just work down your side or use them both. So x squared plus 7x plus 12 is our first question here. So we're looking at seeing if right away is our greatest common factor. Always look for that. Always look for that. Okay. So I'm looking here and I'm noticing, so we have a 1 here, 7 and a 12. 1, 7, and 12. The greatest common factor is just 1. Okay, so they don't all have an x that you can divide up. All right, so that common factor check is done. Now you want to go right to product sum. So I usually do it over here on the side. So the sum of the product of, and again, if you're like, I don't want to write all those letters out, you can just write times, plus, like that if you want, okay? So the sum is always that middle term, 7. And then the product is always the, remember these two numbers, okay? So here it's a 1 and a 12, so the product of 12. All right, so start brainstorming here. What numbers multiply to make 12, positive 12, but add to make 7? So again, if you want to go through all the factors, you can, but hopefully right away you 3 times 4 popped into your head. Okay, so that works. Those are the two conditions, adding to 7, multiplied to 12. All right, so from there, the decomposition method says break apart the middle term. Okay, so replace that 7x with 3 plus 4x, which is from our product sum table here. All right, now factor by grouping. So again, you're thinking, okay, what's the greatest common factor of these first two here? And x can divide out of both. And x can divide out of both. Known numbers can. And the other one, 4 and 12, well, I can divide a 4 out of both. Okay, so factor out the first two. So there's a greatest common factor x, and then what's left? Well, an x is left for the first term, and then a 3. Okay, and then here, if it's 4 is the greatest common factor, so that leaves an x plus 3. Okay, so again, just like before, when you get to the step and the factors here that come out in the brackets aren't the same, something went wrong, so go back and double check your work. And every once in a while there is one that just doesn't work, so it doesn't factor. But with the ones I'm giving you here, the ones we're practicing, it should always work. So if these numbers, like to the exact sign, are not the same, something went wrong with your factoring. All right, go to the next step here, factor out. Okay, so again, hopefully you see that, oh, these two, this binomial here is the common factor, so I can divide that out. And that leaves me with the x plus 4 left. Okay, so I'm going to keep going with that method, and then I'll come back and do the area model together. Okay, so there are the two factors, x plus 3, x plus 4, that's the answer. So let's try the next one. Okay, so we have y squared plus 6y plus 8. Again, look for the greatest common factor. Look for 1. Is there 1? No, it's just a 1. Okay, next step, product sum table. Okay, so the sum of the middle one, which is 6, and the product of the first and the last terms, 8. That 6 looks like a B. Let's make it more of a 6. Okay, so again, brainstorm. What numbers multiply to make 8? So I always look at what products, what things multiply to make the number, and then I figure out what adds up. Okay. Oops. 2 times 4. 3 doesn't work. 4, nope. Okay, so these are the, and again, remember, sometimes you might need those negatives, so always consider negatives as well. Okay, because the negative makes a positive. Okay, but those negatives don't work. Only the positive 2 and the positive 4 work here. So let's break up the terms, decompose. Okay, and so there we go. Decompose the 6y to 2y and 4y. And then we are going to divide a y out of both of these. Okay, no number works. And the other one, we're going to divide a 4 out of both of these. Okay, so let's factor out the first two here. Okay, so that greatest common factor is a y. That leaves just a y left. Again, remember you're just dividing through here. Okay, so you're just going y squared divided by y is y. 2y divided by y is just 2. And then go to the next one. So the 4 is coming out. So that leaves a y plus 2 inside. And then we can go to the next one here where you're seeing that these two can divide out. And hopefully at this step here, you can see that they both have this in common. So it's like you can just take that right out, put it in brackets, that's important, and then y plus 4. Okay, and there is the trinomial factored out. Okay, so we'll do one more, and then I'm going to show you a little trick that can make you do these a little bit quicker, okay, before we get to these other ones here. Let's try the next one here. X squared plus 9x plus 20. Again, we're just using the decomposition method right now. I'll come back and do the area model. So if you want to just, take a look at a few of these, and then if you prefer the area model, then skip to that part of the video. Okay, so step 1, greatest common factor. Look for that. Okay, x squared, 9 and 20. Nope, nothing works, just a 1. So next step, go to the product sum table. So I need to add to 9, but I need to multiply to 20. Okay, so think of all the numbers that multiply to 20 right now. brainstorm and think, okay, which one of those will add to 9? Okay, and hopefully right away you can just think of the 2. Okay, but when in doubt, just write them all out. 3 doesn't work, 4, 5, yeah, there it is. Okay, 4 plus 5. Those are the 2 numbers. All right, so decomposition says break down the 9x with those 2 numbers. Okay, and then go through. I can divide an x out of both of those, and I can divide a 5 out of both of these. And to get to there, and you can see that you can divide x plus 4 out of both of these. And so take that greatest common factor out and write x plus 5. Okay. All right. So sorry, I'll just write a box around this to show you that's not part of the work. Or it's just on the side. That's a product sum table. Okay, so then we'll try this next one here. Yeah, I'll come back and show you the shortcut in a sec. Okay, so let's move on to this one now. All right, so again, greatest common factor. Okay, 6 and 2 have 1, but this one's a 1. The one in the middle is a 1, so that doesn't work. So again, greatest common factor here is just 1, nothing to factor out. Okay, product sum. So again, the sum of the middle term. So pay attention now. I know there's no number here, but there's a 1. But on top of it, there's a minus d here, so it's negative 1. Okay, so I'm just going to write sum of negative 1. That's the condition. And the product, okay, is a and c together. So we have 6, and then the last one's negative 2, so the product will be negative 12. Okay, so you have to multiply to negative 12 now. So you have to think of all the factors that will work here. Okay, so you know that negative 1 and positive 12 will work. You can also, though, take positive 1 and negative 12. But if you're trying to add those up right now, so like the first one will add up to 11, the next one will add up to negative 11. So those aren't working. We need a sum of negative 1. So let's think of the next 2. So 2 times, remember we have to make a negative 12, so one of them has to be negative, okay? Or the other one is negative 2 and positive 6. Okay, so again, if I add those up, you're not going to get a 1 or negative 1. All right, so keep going along. Okay, what else works here? 3 times negative 4, and the other one is negative 3 times positive 4. Okay, so we need it to add to negative 1. So if we have 3 plus negative 4, yep, that one works because the negative 3 plus 4 makes positive 1. So the 2 that we need are these 2. Okay, so it's important which one's negative. All right, so go through and decompose that middle term. Okay, so it's plus 3d. Okay, so remember when we put them back in, put it in with the letter. Okay, and negative 4d, like that. Okay, minus 2. All right, and let's go back to using the colors again. Take the first 2. Okay, what can I divide out of both of those? Well, 3 works. And they both have a d that they can divide out. Okay, and the next one's a little tricky here. We have a negative 4 in front here. Okay, so when we factor these out, we don't want negative inside the bracket, so we want to factor out a negative. What works for both of them? Negative 2. Okay, so like a 2 will divide out a 4 and 2, but then we want to take out this negative as well. All right, so from there, let's write 3d. Okay, and that leaves us a 2d inside. And and 1. Okay, those two just cancel out. All right, and then for the next one, we want a -2, and then so -4. So -4 divided by -2 is a +2, and that's what we wanted. We wanted a positive in here for the first part of the binomial, right? And the next two divide makes +1. Okay, oops, and I just realized I made a mistake here. The one before. Okay, so 3 divided by 3. So 3 divided by 3 is +1. Okay, all right, so that was just me checking to make sure that these two were the same, and they weren't, so I just went quickly and looked back and went, oh yeah, I made a mistake here. It should have been +1 here. Okay, and then from there, one more step, keep going, factoring it out all the way that you can. You can see that this here and this here, okay, put it in brackets. Those are the common factors, so take that out. And you get to your final answer. Okay. All right, so I'm just going to show you kind of just analyze those ones now and just show you some ways that you can, go through this more efficiently. I can analyze the questions that we've already covered. So for example, x squared plus 7x plus 12. So we went through and checked for greatest common factor, and then we looked for the product sum table, found the numbers that 7 can break up into, and then we went through all these steps. So I wanted to show you that whenever there is the a value, okay, so again, remember this is the general form of the quadratic equation here, the trinomial that we're studying. So whenever the a here, okay, if it's a equals 1, so like in this case here, this first one a was equal to 1, okay? The next one here, a is equal to 1. A was c as well. D is a different story, but so for the first three, whenever a is equal to 1, whenever you do the product sum table, okay, so again, if you want to learn things just with one method, you don't want to learn a whole bunch of different methods, just use decomposition the way I showed you, then you're good to go. But I know a lot of you like to use little shortcuts. So if a is equal to 1, so you're going to have x squared or y squared, no number here, but just a 1. You're going to do the product sum table, and then when you get those two numbers, you will actually be able to jump right to the answer. Okay, so you don't have to do all of these steps here. So whenever a equals 1, it finds you the two numbers that are part of your factor. So +3, +4. So all you have to do is write x plus 3, x plus 4. Okay, same with this one. This was a 1. When you did your product sum, you found 2 and 4 worked. So you could jump right to your answer, 2 and 4. Okay, here's another one with 1. So product sum, you found 4 and 5. You can jump right to the answer, 4 and 5. Okay, D here though, the A is not 1, so you can't use this trick. You have to kind of go through the motions, and then you end up with the different factors here. So if you wanted to just kind of try that trick right now, you can try this question. Okay, so here's one to try, x squared plus 8x plus b. So again, greatest common factor. Oh wow, we put the rainbow method on here. So nothing works there, just a 1, right? Let's just switch this back to blue. And then now to the product sum. So we have a sum of 8 and a product of 7. Okay, so you're going through, okay, how will that work? So 1 times 7 is the only two numbers that would make multiply to 7. But 1 plus 7 works. So instead of now going in and decomposing that middle term, you know that you can use this trick now because a is equal to 1. So the trick with the ones that are a equal to 1, you can go right to the answer. Oh, well, my factors here will be these two because that's what I found for product sum. So that's a nice thing about, just being able to use this little trick method. But again, if you prefer just to learn one method that you can use on everything, then just use decomposition, okay? And again, I will show you how to do area model in a second. All right, here's another one. Try this one. x squared. Okay. So if you have to pause the video for a second, do that and try it out. So again, always check for that common factor. Can I divide anything out? Nope. Okay. All right, so I'll do product sum now. Okay, so I need to multiply to positive 9. Okay, and I need to add to negative 10. Okay, so right away, what makes 9? Well, I know 1 times 9 works. I know 3 times 3 works. Okay, and you're sitting there going, okay, if I add those, I will not get negative 10. So then you're like, oh yeah, remember the negatives also work here? Okay, negatives and the negatives. Okay, so of all those negatives, you're finding, oh wait, if I take negative 1 and add it to negative 9, those will add to negative 10. So those are my two numbers. Okay, on top of it, I know my a is equal to 1, so I can use that little trick method, x. Okay, so again, remember the sign's important. Negative 1, bracket, x, negative 9. Okay, so it's a nice little quick way when they're considered to be a simple trinomial. They call these the simple trinomials. Okay, so if the a is equal to 1, then you can just kind of quickly go to that answer, okay, as soon as you find the two numbers from the product sum. Okay, so yeah, just put that under your in your toolbox of something you can just kind of start using to get through these quicker. But again, I know that you just learned how to do this, so if you wanted to just kind of practice with decomposition and just kind of work your way through these steps, because again, it builds on stuff that you learned from before, then do it this way, okay? But keep in mind this new little trick method I showed you, it does not work when a is not 1, okay? So if it's not 1, you have to use where you're multiplying them, and you have to go through these steps here. As we go along, as you practice them, you'll start to see a pattern, so you can start using guess and check. If there are a lot of other methods out there that you can learn if you wanted to, look them up and so forth. Like I think there's an Australian method if you're more of a like to do things with formulas. I'm going to eventually teach you something called the quadratic formula, which will solve any trinomial. But for now, we are looking at getting to factors that are nice whole numbers. So if you're getting a decimal, then something's wrong, okay? Yeah, so there's a few methods out there that you can try, so you can look those up if you want to see something different. I'm going to show you, though, the area model because a lot of people have used it for expanding, and I found that past students have really actually liked using it to factor these instead of the decomposition method. Okay, so we'll go back up to the top here, back to the first example, and we're going to try the area model on it. Okay, so again, just a reminder, remember put the ax squared in the corner. So ax squared goes in this corner, and then the c goes in this corner. Okay, so add those in. Okay, so we have x squared and we have the positive 12. All right, so we still need to do the product sum table. So I could just, I'll just do it another one here. You can look over in the other example, I guess. But okay, so we need to sum to 12, and then we need to multiply 1 times 12 is 12. Or sorry, we have to sum to 7, and we have a product of 12. Okay, so 1 times 12, nope. 2 times 6, nope. 3 times 4, yes. Okay, so 3 times 4 works. 3 plus 4 will add to 7. So again, place them in here. Okay, and again, it doesn't matter which way. If you wanted to write the 4x here, and the 3x here, it still comes out to the same answer in the end. Okay. All right. So from here, it's you're working backwards using this method. Okay. Before you always had numbers on the outside, and then you would multiply in. But now you're going backwards. So when you're going out of the boxes, you're dividing. Okay. When you go into the boxes, you're multiplying. So let's start with, doesn't matter which column or row you start with, but I'll just start at the bottom again. So the 4x and the 12. So this last row here, 4x and 12. What number can I divide out of both? Okay, I can divide a 4 out of both. Can I divide an x out? No. Okay, let's go to the next row here. So right here, x squared and 3x. So can I divide a number out? No, but an x can be divided out of both. So write x. All right, and first column here, x squared and 4x. Any numbers? No, but an x can be divided out. The next column, 3x and 12. I can divide a 3 out of both. I can't divide an x though. Okay, so once you divide everything out here, make sure write your final statement or your final factors. Okay, so away from the box, so x plus 4, x plus 3. Okay, and a reminder, it doesn't matter which way you write it, it's still considered to be the same. So x plus 4 can come first or x plus 3 can come first. Okay, again, I recommend being able to use both methods. This way you can double check your work. But another way to check your work is simply take this, multiply it back in, and see if you go back to the original question. Okay, but reminder, please do your check over on the side in a box so that I don't think that's your final answer and so forth. All right, try the next one. Y squared plus 6y equals 8. So again, we are placing in the x squared. So the first one goes here and the last one goes here. And again, you're still following the steps though of check, is there a greatest common factor? Nope. Okay. Even back up here, was there a greatest common factor? Nope. Okay. All right. And if there was one, you're going to take whatever's in the brackets and put it in here to factor it. All right, product sum. So I need to add to 6 and I need to multiply to 8. So what numbers work? 2 and 4. Those work. Okay, put them in. 2y, 4y. Okay, so again, remember, like with the decomposition method, you were breaking up the middle term. With this area model, you're finding the two numbers here, and then you're going to place them in the box, but you're going to place them in with the variable. Okay. All right, so from there, let's factor. Okay, so the bottom row here, 2y and 8y, a 2 can be divided out of both. Okay, no letters. The first row at the top, y squared and y, no numbers, but a y can be divided out of both. Okay, looking at the first column here, no numbers, but a y can be divided. And the last column, 4y and 8y, a 4 can be divided out of both. All right, and write a answer outside of the box here, away from the box, not outside, I guess, away from the box, and y plus 4, y plus 2 is the answer, okay, the factored answer. Okay, and again, let's move along here. All right, okay, any greatest common factors here? Nope, just the one. Okay, so put the values in. Okay, what numbers work? So I'm just going to look, save time, I'm going to look over here. We already did the product sum. So we found the two numbers are 4 and 5. Okay, so put those into the boxes here. 4x, 5x. All right, and let's factor out, okay, along the rows and the columns. Okay, so the bottom row here, 4x and 20, a 4 can be divided out. The first row here, x squared and 5x and x will work. Okay, the first column, x squared and x. And the next one's 5. Okay, no letters work. All right, and our final answer is 8. There we go. Okay, and we'll move on to the last example here. All right, any greatest common factors that you can think of that will work here? Nope, just a 1, nothing changes. So let's throw these into the boxes here. Okay, so the ax squared and the c go in first. Okay, we do our product sum table. So again, I'm just going to look over on, okay, so let's put that box around product sum table here from the previous question. Okay, so from the decomposition method, we figured out that 3 and negative 4 work. So put those in, 3d, negative 4d. Don't forget those letters. Okay, And on top of the sign's important, which one gets what. All right, let's go through and factor out. Okay, so the bottom row, if you're looking at 3D and -2, nothing works here. No letters work, no numbers work. So you have to put something. So in this case here now, put a 1. Okay, if something else does work, like a D, a letter, then you write it. But if there's nothing that will factor out and the greatest common factor is 1, write a 1. All right, the next row here, we have a 6D squared and a -4D. So we can find that 2 will work for both 6 and 4, and they can both divide out a D. All right, go down, up and down in the columns now. 6D squared and 3D. 3 will work for the numbers, and they both have a D they can divide out. All right, and the last one. So this is a nice example because here was there's no number that works. You have to write a 1. If you are going up and down this way, okay, so if the first one that you see is a negative, that's how you know you have to take a negative out. So if you were like, you're trying to find the factor that goes this way, there's negative, take the negative out. If you were going this way and the first one that you're hitting when you go this way in the row is a negative, you have to take the negative out, okay? But right now it's just positive, so you're okay. All right, but this is a nice example because here you have to take out a negative. What works in both? A 2 will work for both, no letters, and then you're good. So write out your factors now, 2D plus 1, 3D minus 2, and those are the factors. Okay, and that's what we got on the other side as well. All right, so again, I recommend that you learn to use both methods. You will adapt as you go along and practice these. You'll get better, you'll get faster, and yeah, I'm hoping that you'll get to the guess and check method, you know, after a couple cycles, okay? All right, but be able to use both methods. It's always good to have a lot of tools that you can access as you're going through your math learning. All right, the little trick that I guess I showed with the decomposition, the same thing does apply here, okay? If you know that the A is equal to 1 here, then as soon as you get your product sum, it's almost like you can even skip this whole area model and you go right to your factors here, okay? So again, if you know A is equal to 1, product sum 2 and 4, skip right to the factors, okay? So you don't have to do the area model, okay? So again, that only applies if A is equal to 1. So here A was not equal to 1, so go through the area model and find the factors, okay? All right, so that's the lesson for today. I have some practice ones here. Okay, I even labeled them, like here are the simple ones, and that means that A is equal to, where's my pen? A is equal to 1, okay? So that's why you can use that little trick method I showed you, and then keep in mind, these are not equal to 1, so don't use the trick method. Kind of go through the whole decomposition method or the area model method. Okay, and if you like both methods, try them both. Or try one here, try one there. And then go through and then double check your work and practice any of the worksheets that I provide. And if you're feeling awesome, then you can do a checkpoint. Okay? All right. Hope you're hanging in there. I know it's been a lot of work this week, so I'm just gonna see if I can cut it down to just maybe 3 lessons a week, okay? All right, so that way a couple days to catch up. I know it was a short week this week though. All right, thank you.